Welcome to 4.6. Today we're going to talk about slope. Our learning objectives: recognize the slope of a line as a ratio of the vertical rise to the horizontal, distinguish between types of slopes, find the slope of a line, draw a line with the given slope, and model and solve real-world problems by interpreting slopes of simple linear equations as rates. Here's our introductory problem. Make sure to pause the video and read this before moving on. So we're going to start by recognizing the slope of a line as the ratio of a vertical rise to horizontal run and distinguish between types of slopes. If you've ever been skiing, you probably have an idea of what it might be like to learn to ski. When someone first learns to ski, he or she usually starts on a slope that is not very steep. Sometimes that slope is called a beginner's slope. After mastering the basic skills of skiing, a person may begin to try slopes that are steeper and more challenging. In math, the term slope has a similar meaning. In math, the slope of a line describes the steepness of the line. Thinking of a ski slope can help you remember that the slope of a line tells how steep it is. In math terms, the slope of the line is also referred to as m, the rise over run. That is the slope of the ratio of the vertical, or up and down, rise of a line to its horizontal, or left to right, run. So to help us understand this ratio, let's look at the line AB on the left here. So if we were to take our finger and start at A, right here. To move from point A to B, going only up or down and left to right, we would have to go 5 units up and 6 units to the right. That's because the line has a rise of 5 up and a run of 6 to the right. So the slope is rise over run, or 5 over 6. So the slope of our line is 5/6, which is positive. Notice that the line slants up from left to right. Knowing some basic information about the slope of a line can tell you about its slant. So if you'll look here, on the left, the line slants upwards, and a line that slants up from left to right has a positive slope. So we would say that this has a positive slope. On the right here, the line slants down. A line that slants down from left to right has a negative slope. So this one we would call negative. So the first thing we're going to be asked to do is determine whether the line has a positive or negative slope. So go ahead and pause the video and determine these two graphs, whether they have positive or negative, and then hit play and see how you did. What you should have noticed is the graph on the right, if you go from left to, or the graph on the left, I'm sorry, the one with the blue, if you go left to right, our line is going downward. That means it has a negative slope, because again, from left to right, if I start on the left and I work my way to the right, my line is going downward. So we would say that has a negative slope. The graph on the right, if we start on the left side and we go towards the right, you'll notice our line is going upwards. We would say that that has a positive slope. So if the line goes up from left to right, it has a positive slope. If it goes down from left to right, it has a negative slope. There's two other types of slopes that we could have. We could have a horizontal line right here where our slope is 0 because it doesn't go up or down. We could also have what's called a vertical line right here. That's where our slope is going to be undefined. Okay? Because if you look at it, slope is rise over run. If there's no run, we're dividing by 0, and we can't do that in math. Okay, so that's why we would call it an undefined slope. So go ahead and pause the video and find the slopes of each line, and then hit play and see how you did. You should have noticed that the line on the left is horizontal, meaning our slope is 0, and the line on the right is vertical, which means our slope is undefined. Go ahead and pause the video and answer these 3 questions, and then hit play before moving on. So you should know that a slope of a horizontal line is 0, the slope of a vertical line is undefined, and the slope of a line that goes up from left to right is positive. So now we're actually going to go and find the slope of a line. So suppose you're given a graph of a line. You can find the slope of that line by choosing 2 points on that line. Then you count the units to find the ratio of rise to the run. Be sure to consider if the line slants up or down from left to right. This will help you determine if the slope is positive or negative. If we look at a specific problem, we can understand a slope with a positive or negative value. So we've got this line CD on the graph, and we're going to find the slope of that line. So we're given the points C and D. Always start on the point on the left, so we're going to start at point C, because that's the farther left. And we're going to go to D, either going up or down, and then left or right. Always go up or down first. So from C, we need to go up 1, 2, 3, 4, 5, 6 spots. So that means our rise is going to be 6. From there, we need to go to the right 2. That's going to be our run, 2. So our rise over run ratio is 6 over 2. Well, I can simplify that down. 6 over 2 is 3. And the last thing I need to do to figure out if it's positive or negative is I look at the line. Is it going up or down from left to right? Okay. From left to right, our graph is going up. So that means it's going to be positive. So our answer is a positive 3. So now that we're going to do the same thing with line FG. Again, always start with the point on the left. Okay? F is to the left. So I'm going to go from F to G. I always go up or down first, and I have to go down 1, 2, 3, 4 spots. That tells me that my rise is a 4. Then I do my run. 1, 2, 3 to the right. So my run is 3. So my rise over run ratio is 4 over 3. And I can't simplify that down any farther, so I have to leave it as 4/3. The last thing I need to do is I look at where my line is going from left to right. So if I start on the left and go work my way right, my line is going down. Down means negative. So that 4/3 is actually a negative 4/3 for my slope. Next, we're going to draw a line with a given slope. So we know that we can think of a slope of a line as a ratio of rise over run. We can use this ratio to draw a line with a specific slope. Let's take a look at how to specifically draw that line with a slope. So we are asked to draw a line that goes through the point -4, -1, and has a slope of 3/7. So the first thing we do is we find this point right here, -4, -1. Remember, coordinates go x, y. So if my x is at -4 and my y is -1, that puts my point right here, -4, -1. Now, from there, I'm given my slope. Remember, slope is rise over run. So my rise is the top number. I'm going to go up 3. 1, 2, 3. My run is the bottom number. That's a 7. So I'm going to go 7 to the right. 1, 2, 3, 4, 5, 6, 7. And that ends right here at this point in yellow. So my line connects those 2 points. So it's going to look something like this. Got another example here. Now we're going through the point -5, 4. So that's the first thing I do. X is -5, y is 4. So -5, 4 is right here. -5, 4. So then again, rise over run. Now one thing that's different is you'll see a negative here. This negative always goes with the top number. So my rise is a -2. That means I'm going to go down 2. And then my run is the bottom number of 3. 1, 2, 3. That puts my point right here, and I can connect the two with a line. Here's the line that passes through -5, 4 and has a slope of -2/3. So how can we use this for real-world problems? Sometimes we can use the graph of a straight line to model and solve a real-world problem. In that case, the slope of the line represents a rate of change. We can use what you know about rates and slope to help us work through these problems involving rate of change. So Becca sells necklaces to make extra money. This graph shows how the total amount she earns for her necklaces increases depending on the number of necklaces she sells. So the first thing we're going to do is we're going to find the slope of the line on the graph. So if you'll notice, we've got the point 1, 3 and 2, 6. So from 1, 3 I have to go up 3 and right 1. Okay, up 3 and right 1. Remember, slope is rise over run. My rise is 3, my run is 1, 3 divided by 1 is 3. Going up from left to right means it is a positive 3, so my slope is 3. Use the slope to determine how many dollars she charges for each necklace. Well, if you'll notice, she sells one necklace for $3 and two necklaces for $6. This slope right here, that tells you how much she charges per necklace. You'll notice that the slope is the same as the answer for part B. Okay, so now we're going to make a table to show how much she earns if she sells 0, 1, or 4, or 1, 2, 3, or 4 necklaces. So X and Y. Okay, our X's are the necklaces, 1, 2, 3, and 4. The Y's, well, we already know what 1 and 2 are. So now you'll notice we added 3 here. So we keep adding 3. So 6 plus 3, she would make $9. Plus another 3, she would make 12. Okay, so this is how much she would make off of those, or selling that amount of necklaces, because we're adding our slope every time. Here's the original problem solved. Make sure to pause this and read through it before moving on. So for review, to find the slope, find the rise of the line and divide it by the run of the line. A negative slope will be slanting downward from left to right, while the positive slope will be slanting upward from left to right. The slope of a line describes the steepness of a line. It's described as the rise over run. The rise is the number of units that you move up or down from one point on the graph to another. The run is the number of units that you move left or right to get to the next point on the line. A line that slants up from left to right is a positive slope. A line that slants down from left to right has a negative slope. The rate of change is the change in the y value divided by the change in the x value for 2 points on a graph. A linear equation is an equation that represents a line. In an equation that represents a line, the coefficient of x represents the slope. The coefficient of a term is the numerical part of the term.